Some GPS receivers have built-in hardware and firmware for displaying the computed position and other information. Other GPS receivers need to connect to another device to provide the user interface. Those devices that will display the GPS position, as well as provide data collection functionality, are called data collectors. There are a number of different brands of proprietary handheld GPS data collectors on the market that only run the software provided by the manufacturer. There are other handheld devices that will run third-party GPS data collection software that is compatible with the operating system used. For example, the Magellan Explorers Pro 10 and the Juniper Systems Archer 2 PDA will run GPS data collection software compatible with the Microsoft Mobile 6.5 operating system. These come with built-in SBAS-enabled GPS, and typically provide 3 to 5 meters horizontal position accuracy in real time. Nowadays, a number of smartphones are able to run GPS data collection apps to double as GPS data collectors. For example, iPhone devices and some models of iPad devices have built-in GPS and are able to run third-party data collection apps. These devices provide location-based services using cellular-assisted GPS and crowdsourced Wi-Fi information. To obtain better precision accuracy, iPhone and iPad devices can be connected with compatible external GPS devices through Bluetooth. In fact, high-accuracy work can be performed by using a high-precision GNSS receiver with a powerful GPS data collection and mapping application software. For this training program, our focus will be on using an iPhone device or an iPad device running a CMT GPS Gis data collection app. The iPad device will need to have a built-in GPS or be connected to a compatible external GPS device. If you're using the recommended hardware and software, you will be able to follow the instructions closely. If you're using some other data collector or software, then you will likely still be able to gain an understanding of the concept and general procedure of GPS Gis data collection and mapping by watching these videos.
Can I use any Bluetooth GPS receiver with my iPhone or iPad?
Not all Bluetooth GPS receivers work with iPhone and iPad devices. You will need to use an iOS-compatible Bluetooth GPS receiver. For your information, there are connectors available for connecting various GPS receivers with an iPad or iPhone device.
A complete GPS Gis system typically consists of a GNSS receiver, a data collector running data collection, and/or navigation software program, as well as an office computer running GIS software. The software running on a GPS data collector will provide the user interface for recording location data for geographic features. Some application programs also provide navigation, digitizing, mapping and computation functions. More sophisticated apps may even let the user set error limits to ensure that only high-quality GPS data are recorded. In this training program, we will cover the general GPS data collection functions, as well as a number of specific functions provided by the ICMT GIS 3 and the ICMT GIS Pro software, which can run on an iPhone or an iPad device. Once you have become familiar with the user interface of the app, you can explore the other functions by consulting the help document for the app. On the screenshot of iGPS Gis 2, running on an iPhone device, the blue dots indicate the recorded GPS points, the green line indicates a line feature being recorded, and the red triangle indicates the current position of the GPS receiver or its antenna. With ICMT Gis 2 running on an iPad device, and a background map loaded, the data collection screen will look similar to this. From this point on, we will show sample screens captured from ICMT GIS2, ICMT GIS3, or ICMT GIS Pro, running on an iPad device, as these screens are larger, and will show more data collection details on the same screen. The normal workflow of a GPS GIS data collection job includes uploading the collected data to a computer running a GIS software program. The collected data would be organized, analyzed, summarized, combined with other data, or disseminated for use by other people. The field data files stored on the ICMT GIS3, or the ICMT GIS Pro app, are compatible with the PCGIS mapping software. ICMT GIS3 and ICMT GIS Pro can export the collected data in various formats. For example, the data can be exported as shapefiles, for use by other GIS software programs that are capable of working with shapefiles. In this training program, we will use PCGIS to view the recorded data, and prepare a finished map, for printing out or saving to a PDF file. We will cover a number of essential PCGIS functions, that will be applied to the field data we have collected. For details about the other functions provided by PCGIS, please read the online manual included with the software. Here is a sample screen, captured from PCGIS running on a PC. Although there is an overlap of some functions provided by ICMT GIS Pro and PCGIS, it is obviously more convenient to work with a larger screen, and type on a physical keyboard. GPS GIS work mainly concerns geographic locations, and information associated with those locations. When we speak of a location, we will need to specify the coordinate system, to which that location is referenced. On the horizontal plane, a location is usually defined by a pair of numbers, indicating how far the location is from the origin of the coordinate system used. On a chessboard, for example, the position of a chess piece is indicated by its rank and file designation, such as A1 or E4. The A1 or E4 coordinates have meaning only on a chessboard. They are not tied to geographic locations. Therefore, knowing A1 or E4 tells us nothing about where exactly in the world the chess piece is located. On the other hand, if we are given the latitude and longitude for a chess piece, then we will be able to find out in which city or neighborhood that chess piece is located. Specifying the latitude and longitude is one of the many ways to denote a location on the surface of the Earth. The surface of the Earth's gravity field, which is approximately the same as mean sea level, is called the geoid. The shape of the geoid is irregular, because the mass of the Earth is not uniform, and the direction of gravity is different at different locations. Therefore, we use an ellipsoid, also called a spheroid, to represent the globe of Earth mathematically, so that we can affix a coordinate system to it, to describe locations. An ellipsoid, that defines the shape and size of the Earth, along with the reference points used for a coordinate system, to map locations on the Earth, is called a geodetic datum. These are the three most commonly used coordinate systems in the USA. The Geographic Coordinate System, also known as the LLA system, is based on a realization of the horizontal datum named World Geodetic System 1984, or WGS-84, and the North American Vertical Datum of 1988, or NAVD-88. The latitude lines run in the east-west direction, and are parallel to each other, with 0 degrees assigned to the equator. The latitude increases from 0 to 90 degrees, as you move north from the equator. It decreases from 0 to -90 degrees, as you move south from the equator. Another way to express a negative latitude is to add the designation S to the corresponding positive value, as in 44 degrees S. The longitude lines run in the north-south direction, with the prime meridian passing through Greenwich, England. As you move east from the prime meridian, the longitude increases from 0 to 180 degrees. As you move west from the prime meridian, the longitude decreases from 0 to -180 degrees. Another way to express a negative longitude is to add the designation W to the corresponding positive number, as in 120 degrees W. The altitude in the LLA system is usually expressed in meters. The Universal Transverse Mercator Coordinate System, or UTM, divides the globe into 60 zones, and projects each onto a separate plane on a cylinder. The XY coordinates are usually expressed in meters. The central meridian of each zone is assigned the arbitrary value of 500,000 meters, called the false easting. The equator is assigned a northing of 0 for the northern hemisphere, and a northing of 10 million meters for the southern hemisphere. Older maps in North America are based on the North American Datum of 1927, or NAD 27. More recent maps are based on the NAD 83 datum. Older GPS receivers as well as Google Maps and Bing Maps use WGS 84. Recent GPS receivers use the current WGS 84, 1674, ITRF-08 datum. The State Plane Coordinate System divides the United States into 124 zones, and projects each onto a separate plane. The XY coordinates are usually specified in a survey feet. Each state plane is specified by the name of the state, the region number and a zone number. The current realization of North American Datum of 1983 is NAD 83, 2011. Older maps in the USA are based on NAD 27. The CMT GPS Gis Data Collection apps can let you set up a local and easy plane. They will also work with user-defined coordinate systems that you define in PCGISX. In the same way that apples cannot be likened to oranges, when looking at a set of coordinates, it is essential to know which datum and coordinate system they are based on. This is particularly important when you are combining map data. This is particularly important when you are combining map data from various different sources.